I'm excited for this hangout. I just got a really good question about resonators and what they are and how they work. Resonators are parallel bandpass filters that are harmonically tuned and then have tight delays, oftentimes combing filter or phaser type delays after the bandpass filters. So to give you an idea of what a resonator actually sounds like, let's just do a little quick fun experiment that I like. In fact, we just need white noise. So I'm just going to grab an operator, just a little synthesizer here, and I'm going to choose my wave to be white noise, and I'm going to turn my sustain level all the way up. Now if I hit a key, I've just got every frequency at a fixed amplitude, but no resonance, no sustaining pitch at all. If I take a resonator plugin, which does it all for us, I simply can hear this by turning the dry-wet mix up, and I can tune each of my 5 bandpass filters. Let's start with just one, and I'll keep this filter off. So this is essentially a combing filter, but I can tune the filter. It doesn't become amazing really sounding until you start harmonizing it. So like, let's go up a fifth. Turn that on. Listen to this, and maybe up a fourth as well, just for good measure. And this is, let's go down an octave and then down 2 octaves. The 2 octaves is too low, but now I can mix my partials. I could even say I just really want the super low one. This one, these are panned, so you want to probably have this one there too. Now we can mix in our overtones. So as you can hear, this is why they give you an input filter, especially if you're running something just clangorous and mayhem-y like white noise. Check it out. So what this is really doing, though, is, again, a bandpass filter and a delay. So to build just that first resonator, all you need is this. The thing is, you'd have to know which frequency is which note. So I happen to know that 132 Hertz is like a low C. So let's just put it at C and just jam this thing up to add coloration. What we would do is we'd then group this, put our delay into the group, and then we'd say amounts we could put right here. So brightness of our first band. And then on that first band, we'll say tune. Now we add a resonator, or I should say, kind of a combing filter style delay in mono. So we take it out of sync because we don't want an echo. We want a really tight delay. Let's go ahead and put a spectral analyzer on here, and we can watch those new harmonics kind of pop up. This is essentially a combing filter. Even without this, it's a combing filter. Watch. That's called a combing filter. Essentially, you're accumulating phase cancellation at great amounts by adding feedback. And the frequencies that are being canceled are controlled by this delay time. So this is a really desirable sound, especially when you attenuate the overtones ahead of time. So imagine having one of these on each of your fingers, where you have one for your bass note, the thumb, but then you also have one for your pointer finger, and then one for your middle finger. I'm saying fingers because it's like you're playing chords. We're making chords. This is now, we could make a triad out of this if we were only smart enough to tune these frequencies correctly as they relate to these delay times. Because if right now they don't. They're just nonsense, and so it's going to be really hard to dial it in. What I might even recommend if you're going to build your own DIY resonator is make a rack of just filters and then put one delay on the end of it. So when you don't have all these individual delays to babysit, you just have, let's say, 3 bandpass filters, each of them having just getting mixed collectively to then 1 delay. So now we could try some fun stuff. In this case, I'm going to get rid of the resonance, and I'm just going to go tone, tone, oops, tone. So I'll go hertz, I'll just go thumb, pointer, middle. And we could have a global resonance. That could be cool. That'll be a really fun sounding function. So this will be an overall amount. So all of them will have one big resonance amount. So we'll call this amount. Now, we could just use a macro for feedback and a macro for delay time. But this is not in the same rack anymore because we have to group these, right? Because I can't put this out to a macro. So I got to go shift, group. Now, thumb, pointer, middle, amount, and then we'll go delay time, feedback. Let's try it out. You know, the only thing I really want, finally, is I want gain. I want a volume control. Shoot. I almost want to put feedback up here and forget about this amount one, and then have volume for each 3 of these. I think that would be better. So feedback, time. Okay, I'm going to try it. Let's move time up to this amount guy. We're going to call this time. And then amount, we have to get rid of the resonance on these filters. We have to ditch this, unmap it on all of these. So amount is just up. And time now. Oops. I can't rename you. That's fine. Time and feedback. These are our delay controls, so we'll make them green. Because, I don't know, reggae. Because reggae. Feedback. Time. These are our... So now we just need volume for each of our chains. We're doing it, guys. Thumb volume, pointer volume, and middle volume. Wait. Where's my language? 5, 6, 7. I blame the tea. I'm all caffeinated here. So this is thumb volume. We're making our own resonator. Believe this? Middle volume. Neat. Okay, so let's try it now. Yeah. You hear what was going on? My delay times were going way up into like the half of a second range. So for a proper phaser delay, like a combing filter delay, we want the max to be about 35 or 40 milliseconds, and that's like way the max. So I'm going to go up here to this time delay. I'm going to say U45. It'll be really flangery. So now I'm safe. So this is a sound design machine. I'll call it a DIY resonator, but it's not quite done yet. You guys ready for the final element that it really needs? It needs modulation to these filter cutoffs. I want these things to move a little bit. You could do that with the built-in LFOs, or you could totally use a Max for Live LFO. That could be a lot of fun. I think maybe just going ahead and saying, we might need to appropriate, I mean, this is where things get tricky. You either need to make macros for our LFO control, kind of in a pinch. But I'd like to have a little bit of global motion. We have macro 8 available here. So let's go ahead and do a little fun stuff. I'm going to slow this down and put it in stereo. I'm going to have all these at different rates. I'm just going to go LFO amount. All nice and slow. So this will just be the smear knob, which I think is actually going to be really rad. If we were really smart, we'd probably have the middle finger one be faster, and then the thumb one would be slowest, because that's the lowest frequency, like bass note usually. So we might want a slower rate for the bass sounds, and then a slightly faster rate, and then once we get higher in the frequency range, faster motion is okay. That's assuming that we're using this kind of in chronological order and tone there, if you will. So that's some really deep shit. But now this is our smear control. Let's try it out. Since they're all in stereo a little bit and out of sync, this could be pretty rad. Let's try it out. Put your headphones on. Wow. So there you have it. Voila. I improvised through this entire thing, but I think in the end it turned out pretty cool. I'd probably color code these. Maybe go like red, orange, little rainbow time. This is a Rasta, yeah, dub noise machine. So now I just throw this in my library. Boom, look at all those. So this is James Patrick, and I'm with Slam Academy. I'm an Ableton certified trainer, and Slam Academy is an Ableton certified training center. We're the only one in the upper Midwest, and we're happy to offer online classes, short courses, and full programs in Ableton Live, sound design, and other exciting topics. So hit us up at www.slamacademy.com for more information. Thanks a lot.